So welcome to the live interactive session number 8 for the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today we are going to discuss some sample problems which will be useful for solving the assignment number 9. Is the screen visible? Hello, am I
Yes,
audible?
yes.
So the first question, for a 090 symmetric graphite epoxy laminate subjected to only NX, which of the following is true? So when there is, as you can see in the diagram, 090 symmetric will be in such a way that the fibers are aligned in 0 degree, then 90, then again 90 and 0. So now it is saying that the laminate is subjected to only NX. So NX, NX is the X direction which will be considered for, which will be the longitudinal direction for a 0 degree laminate. So as you can see in the diagram, the longitudinal direction of the 0 degree laminate is in this way. And as we know, for 0 degree, in the longitudinal direction, the fibers are aligned. So the strength in that direction will be the highest. So if the NX is applied in parallel to the direction of the fiber, then it will be able to withstand higher stress. Whereas for 90 degree, it is perpendicular to the 0 degree. So when the force when it is subjected to a load in this direction, which it will be transverse to the 90 degree angle fiber aligned in the laminate. So as we know that always the transverse tensile strength is lesser than the longitudinal tensile strength. So for the 90 degree laminate, the tensile strength is lesser in the transverse in which the load is subjected on the laminate. Therefore, it has higher chance of failing first. That's why the option will be that 90 degree laminate will fail first in the transverse tensile mode. The next question, two laminates with identical dimensions and made from the same glass epoxy laminate with same lamina thickness but with stacking sequence 0 plus minus 45 0 symmetric and 0 0 plus minus 45 symmetric are subjected to same axial load tensile load. Then which of the following is true? So first we will think about the ABBD matrix. As you can see, both are symmetric. Both are symmetric in their stocking sequence. So the B matrix will be 0, and there is only axial tensile load is applied to it, and there is no moment, and so there will be no curvature. So because of that, the D matrix will also be 0. So what is left is A matrix. So here you can see the equation of A matrix. It is dependent on the thickness of the lamina and also the reduced stiffness matrix of each laminate, and it is the summation of it. So in both the cases you can see the layers and their thickness is same and the angle is same, only their sequence is different. So when their stiffness matrix, reduced stiffness matrix and the thickness multiplied and then they are added to find the A matrix, it will be equal for both of them. So we will get the same A matrix for both of these sequences because the angles and the angles in symmetry are same. So now here in the options they talked about the mid surface strain. So we know the equation that the Nx is equal to the A matrix and the strain, the mid surface strain. So from this equation, when we take the inverse of A matrix, we can find the mid surface strain. And so mid surface strains is directly proportional to the A matrix, as the A matrix is equal for both of them. So mid surface strain will also be equal for both the sequences. Next question is 090 plus minus 45 symmetric laminate is subjected to only Nx and Ny, and the stresses at the mid of top 0 degree ply was found to be sigma x 30 megapascal, sigma y 15 megapascal and tau xy equal to 0. If the same Nx and Ny are applied to another laminate made from same lamina but with the stacking sequence 090 plus minus 45 3s, so that the number of lamina is increased to 3 times. So the stress at the mid or top 0 degree ply will be. So here again it is symmetric, so the B matrix will be 0 and there is no moment or there is no curvature, so the D matrix will also be 0. So what we have to consider is A matrix. So again, for the first talking sequence 0, 90 plus minus 45 symmetric, we get an A matrix, and for the second one it is 3 times in thickness, the 3 times of the first one. So the A matrix will also become 3 times of the first one. And as you can see the equation of Nx Ny in terms of mid surface strains. So to find the mid surface strains, we have to inverse the A matrix. So when the stocking sequence is increased 3 times, when we will take inverse of it, it will become 1 by 3. So the strain, mid surface strain, will become 1/3 of the initial one. And if strain is becoming 1/3, then the stress will also become 1/3. So as here given sigma x as 30, the 1/3 of it will be the answer, that is sigma x will be 10. The sigma y will be 15 divided by 3, 5, and tau xy will be 0. So this is the answer. Then the next question, the reduced stiffness matrix of a unidirectional graphite or epoxy lamina is given, and the strength parameters of the unidirectional graphite epoxy lamina are given, and the thickness given is 0.1 mm. So the question they asked is, if a 090 symmetric graphite epoxy laminate is subjected to an in-plane load of Nx 100 Newton per meter, the mid-surface normal strain induced along x direction sigma x naught is, we have to find. So here again the laminate is symmetric. We will again consider the ABBD matrix. So the B matrix will be 0. Only in plane load is given, and so there will be no curvature, and there will be no moment is given. So the D matrix will also be 0. So we have to consider A matrix. Now, before, as you have seen, the equation of A matrix equal to summation of the reduced stiffness matrix and the thickness of the laminate. But and here in the question, the reduced stiffness matrix is given, which we will consider for the 0 degree alignment of the fibers. And for 90, what only we have to do, we have to interchange the values of Q11 and Q22, and we will get the 90-degree laminates Q matrix. So putting these values, the thickness is given 0.1 mm, and there are 2 of 0 degree and 2 of 90 degree. So we will multiply with 2, and we have to take care of the units, and we will get the A matrix. Now it is given that Nx is given 100 Newton per meter. So Ny and Nxy is equal to 0. The same equation that we have seen before, of the load and the strain. So putting the values in that, we will get two equations where the unknowns are sigma naught y and sigma naught x. From two two unknowns, we can find the values of sigma x naught and sigma y naught. So what they asked in the question is, sorry, eta x naught. So we will find the value of eta x naught from this equations. Next question is a continuation of the last one. Here they ask that if the 090 symmetric graphite epoxy laminate is subjected to only Nx, then the first ply failure load using the maximum stress criteria is. So we have to find the first ply failure load here according to the criteria of maximum stress. So in the last question, we already found the mid-plane strains in x and y direction. So these are global strains. So we have to, these are given as the mid-plane strain. So we have to find the strain of the whole laminate, mid of each ply. So to find that, the equation is given here, but here kx, ky, kxy is equal to 0 as there is no curvature. So we will find that the global strain in each ply is equal to the mid-surface strains. Now we need to find the global stresses at the mid of each ply, which can be obtained by the help of the stiffness matrix of each ply, reduced stiffness matrix of each plies from this given equation. After solving this equation for the 0 degree and 90 degree, you will get the data in form as that can be shown here in the form of this table. So these are the global stresses at the mid of each ply in this table. Now we have to find the local stresses at the mid of each ply, because in the question the strength parameters are in uh, local stresses. So we have to find the local stresses at the mid of each ply, which can be found from the global axis. We have to transform it into local axis by multiplying it with this transformation matrix for both 0 and 90 degree lamina, and then we will get the values as you can see in this table. These are in the form of the local, these are the local stresses at the mid of each ply. Now the conditions given in the question, so we have to find the stress ratio comparing to the condition, the strength parameters that are given in the question. So the first, for 0 degree lamina, the stress ratio for sigma 1 for 0 will be compared to the sigma 1 ultimate. So which stress ratio is found as a sigma 1 divided by the ultimate. So this is the value you will get. For sigma 2, the ultimate tensile in ultimate transverse is given, that is 40 megapascal, and here you have got the value, and when we divide we get the stress ratio. Here you see in the 90 degree it is given in negative, so whenever it is given in negative it is compressed. So then for that we have to consider the sigma 1 in the ultimate value for the compression load, and divide it by the compression load to find the stress ratio. So when we compare the stress ratio, all the stress ratios, we can see that the stress ratio 2 for the for 90 degree in the transverse direction is the highest, which means that it has higher value of reaching 1, and when it reaches 1 that means failure. So when so from this value which is closest to the 1, we consider it at the condition which will fail first. And now from this value we have to find what will be the first ply failure load. So the load which is given is 100 Newton per minute. So for that load we are getting the stress ratio as 0.000591. So we have to find the load at which it will become 1. So by using unitary method we can find that at 169.49 Newton per mm. We will find there will be failure, that is this stress ratio value will become 1 and the laminate will fail. The first ply will fail, which will be 90 degree in transverse direction. The next question is to find the value of 826 in the ABBD matrix of 090 symmetry graphite epoxy laminate. So A matrix we already solved in this previous question in question number 4. So from A matrix you can find the value of 826 comparing it with this. So the 826 value is here, we found 0. So the next question is for an angle lamina where the transform compliance matrix values are given, and in the question it is given that the longitudinal transfer coefficients of thermal expansion for a unidirectional carbon epoxy lamina are given, that is alpha 1 and alpha 2 respectively, and the coefficients of the compliance matrix are given S11, S22, S12, S16, S26 and S66. So the angle, if a 45 degree carbon epoxy lamina is restrained along y direction and is cooled down from 120 degree to 70 degree, then what will be the normal stress induced along y direction? So in the question, the main point we have to see is that it is restrained along y direction, that is the strain along the y direction will be 0. So now we have the values of the transfer compliance matrix is given. So we have to put this value, and for, we know the equation where compliance matrix is used. We have is the equation where given the strain by using the compliance matrix we can find the stresses. Now strain here is also because of stress is because of stress and also because of the temperature difference. So the total strain in global axis will be equal to the compliance matrix into the stresses in the global axis plus the thermal coefficients in global axis into the delta T. Now the conditions given in the question is that it is restrained along y direction. So eta y will be equal to 0, and we have to find the normal stress induced along y direction. This is the only value we have to find. So we have considered that the stress we need is only in y direction. So the x direction stress will be equal to 0 and also tau xy will be equal to 0. After putting these values, we will find this final equation of sigma y in terms of alpha y, delta t and s bar 2p. So in the question already given the value how to find the transform compliance matrix. So S22 bars to find the value of this, the equation is given where the value of S11, S12, S66 and S22 is already given in the question. S is the sine of theta and C is cos theta and the theta given is 45 degree. So from that we can get the value of S22 bar. Now next is we need the value of alpha y, which is the thermal coefficient in the global axis. But in the question we are given the thermal expansion coefficients in terms of material axis. So we have to transform from material axis to global axis. For that we have to multiply it by the transforming matrix and we can find the values in the global axis of the thermal expansion coefficients of thermal expansion. We got the value of alpha x, alpha y, alpha xy. We put the value of alpha y in the equation. Delta t is given in the question, and we can find the value of the sigma y, which is equal to here 15.4 megapascal. Next question is the longitudinal and transverse coefficient of thermal expansion of a unidirectional graphite epoxy lamina are given alpha 1 and alpha 2. So if a 0-degree graphite epoxy lamina is fully restrained and experiences a temperature change of delta T 60 degrees Celsius, what will be the nature of stresses induced? Now it is fully restrained. So in transverse, longitudinal, every direction, the strain will be equal to 0. So if there is strain equal to 0, then the stress will be compressive stress. And when there is compressive stress, then the value of sigma is negative. So because of change in temperature, there will be expansion, but because it is restrained, it will give a force in the opposite direction, which will be compressive stress. So the values of sigma 1 and sigma 2 will be negative. Any doubts? Vishwas, do you have any doubts in the questions that I explained?
No, no, ma'am.
Have you tried the
Actually, I don't have any questions, doubts in the questions, but just I wanted to ask some questions. Some answers are lengthy. We have to do a lot of calculations, right? So, in the final exam, is there going to be a more weightage marks or maximum weightage is only 2 marks?
that I don't know. That will depend on NPTEL how they make the question paper.
Okay, okay. Because for 1 marks, whatever time we invest, so when it is for 2 marks, actually it takes more time while doing all the calculations. And in the calculator which they are providing in that exam, that is also again it's a new thing for us. So some matrix calculation when we want to do here, when we are doing, we are using our own calculator. So we know how to reduce time, but there again it will take time for calculation. So according to time requirement, are they going to fix the marks, or is it going to be like this only?
No, no, I think they will consider the time, how much it is taking, and accordingly they will make the question paper. But yeah, if you have like, you can ask this question to the live session when sir will come. Maybe he will know how question paper they have set. He will be
Okay,
able to
okay,
answer.
okay.
Okay, then if you have no doubts, then we will end the session here. Thank you.